The calculations have been done, and they are absolutely stunning. Following yesterday's confirmation of Atlas's non-gravitational acceleration, Avi Loeb ran the numbers, and what he discovered will fundamentally change how we view this mysterious object. According to the laws of conservation of momentum, Atlas should have lost at least 1/6 of its entire mass during its close passage to our star. We're talking about losing billions of tons of material in just 1 month. But here's the problem. We're not seeing the massive gas cloud that should accompany such enormous mass loss. This discrepancy between physics and observations is leading to an inevitable conclusion that's sending shockwaves through the scientific community. The Atacama discovery that changes everything? The breakthrough came from data obtained by the Atacama Large Millimeter Array, one of Earth's most sophisticated radio telescope networks. On the 29th of October 2025, ALMA detected that Atlas was 4 arcseconds away in right ascension from where it should be if its trajectory were dictated purely by gravity. 4 arcseconds may sound minuscule, but in astronomical terms, this represents a massive deviation that can only be explained by forces beyond gravity acting on the object. As soon as Avi Loeb learned of these results, he immediately applied the laws of momentum conservation to calculate what this acceleration would mean for a natural comet. The physics is straightforward, but the implications are extraordinary. For Atlas to accelerate this much through cometary gas ejection, the nucleus would need to lose at least 1/6 of its total mass. The calculation reveals that the total evaporation time would be less than 6 months. Since it took about 1 month for Atlas to cross the perihelion distance scale of 203 million kilometers, it must have lost at least 1/6 of its mass during that single month. The missing mass problem, this is where the story becomes truly intriguing. Previous measurements by the Webb telescope showed a mass loss rate of 150 kilograms per second, which produced no detectable non-gravitational acceleration in the 5 months prior to October 2025. This led Loeb to conclude that Atlas's mass is at least 33 billion tons. If the object lost 1/6 of that mass, the dense cloud around it should carry at least 5.5 billion tons of material. This means we should be detecting a massive, visible gas cloud around Atlas right now if the non-gravitational acceleration resulted from natural cometary evaporation. The December observation window. On the 19th of December 2025, Atlas will come closest to Earth at a separation of 269 million kilometers. This represents the best observational opportunity in human history to study this mysterious object. Hundreds of ground-based telescopes, along with the Hubble and Webb space telescopes, will be pointed directly at Atlas. Between the 27th of November 2025 and the 27th of January 2026, Atlas will be monitored by the International Asteroid Warning Network campaign, the moment of truth. If the extensive observation campaign fails to reveal a massive gas cloud around Atlas, then cometary evaporation would not constitute a natural explanation for its non-gravitational acceleration. As Avi Loeb states, if we do not observe a massive gas cloud around Atlas in December, then the non-gravitational acceleration reported near perihelion can be regarded as a technological signature of a propulsion system. This scenario brings an eerie sense of déjà vu. The first interstellar object, Oumuamua, exhibited non-gravitational acceleration without showing any signs of gas or dust around it, even after deep observations by the Spitzer Space Telescope. This led comet experts to define Oumuamua as a dark comet, a comet that shows no visible tail. But as Loeb points out, given that a tail is the defining signature of a comet, the notion of a dark comet is an oxymoron. A spacecraft with a propulsion system could show non-gravitational acceleration without cometary evaporation. As Loeb eloquently puts it, it could be classified by comet experts as a dark comet in the same way that a cave dweller would classify a cell phone as a rare stone. The stakes of this observation campaign have attracted attention from science communicators who are making strong statements about Atlas being definitively natural. However, Avi Loeb points out a crucial distinction. Scientific truth is not decided by popularity contests, but by attention to data, especially when it's anomalous. While communicators make sweeping statements, Loeb has written 11 scientific papers in recent months specifically about Atlas, systematically documenting and analyzing its unprecedented anomalies, the 9 impossible anomalies. The challenge remains for anyone claiming Atlas is natural to explain all 9 documented anomalies. First, the impossible trajectory. Atlas arrived on a trajectory perfectly aligned within 5 degrees of the ecliptic plane, the same plane where all planets orbit. For an object coming from interstellar space, this precision is statistically almost impossible. It's like shooting an arrow from another continent and hitting exactly the center of a target. Second, the physics. Defying jet. Comets normally eject material in the direction opposite to the sun due to solar heating. Atlas does the opposite. Its jet points directly toward our star, violating everything we know about cometary behavior. It's like seeing water flow upward in a waterfall. Third, the size and speed contradiction. Atlas's brightness suggests a small object, but its velocity indicates something much more massive. This fundamental contradiction challenges our basic laws of orbital physics. It's like seeing a small car with the inertia of a truck. Fourth, the perfect timing. Atlas arrived at the exact moment for close encounters with multiple planets in sequence: Earth, Venus, and Mercury. This perfect synchronization is extraordinarily unlikely for a natural object wandering through space for millions of years. Fifth, the industrial metal composition spectral analyses reveal a metal-rich composition that resembles industrial alloys more than natural cometary materials. It's like finding stainless steel in a rock that should be made of ice and dust. Sixth, the extreme dryness. Atlas is the driest object ever observed in the solar system, completely challenging the basic definition of a comet. Comets are dirty snowballs, but this object shows virtually no water content even when heated by the sunday. Seventh, the impossible polarization signature. Light reflected by Atlas shows polarization patterns that don't match any known natural material. It's as if the object's surface has artificial optical properties that don't exist in nature. Eighth, the WOW signal connection. Atlas's direction of origin suspiciously aligns with the location of the famous WOW signal, the strongest radio signal ever detected that may have extraterrestrial origin. This directional coincidence is statistically disturbing. Ninth, the impossible blue brightness. As Atlas approaches the sun, it's getting brighter and bluer, the opposite of what should happen with a natural comet. It's like seeing an object get colder while approaching a heat source. Technological signature, or natural phenomenon. We are now approaching the most critical observation period in the history of interstellar object studies. The December 2025 observations will either detect a massive gas cloud, supporting the natural comet hypothesis despite all other anomalies, or fail to detect the expected cloud, providing what could be considered the first confirmed technological signature of an interstellar object. If Atlas shows non-gravitational acceleration without the accompanying massive gas cloud that physics requires, we would be looking at the first confirmed evidence of extraterrestrial technology operating within our solar system. This wouldn't be ancient evidence or distant signals. This would be active technology demonstrating controlled propulsion under direct observation by humanity's most advanced telescopes. The coming weeks represent a unique moment in human history. We're not just studying an unusual object, we're potentially witnessing the first real-time observation of extraterrestrial technology in operation. The physics is clear. Massive acceleration requires massive mass loss. If we don't see the gas cloud that should accompany such mass loss, we're left with only one explanation that fits the data. As we approach December 19, when Atlas reaches its closest point to Earth, hundreds of telescopes will be searching for 5.5 billion tons of missing gas. If that gas isn't there, we'll know we're not looking at a comet. We'll be looking at something far more extraordinary, a piece of technology from another world, demonstrating propulsion capabilities that challenge our understanding of physics itself. The countdown to potentially the most significant discovery in human history has begun. In just a few weeks, we'll know whether we're truly alone in the universe or if we're currently observing our first confirmed visitor from the stars. Stay tuned. because we're about to witness either the most unusual comet in cosmic history or humanity's first confirmed encounter with extraterrestrial technology.